Hello everyone, in this video we are going to solve this interesting algebra problem. We have a really good exponential equation. We have 10 to the x plus 11 to the x plus 12 to the x equal to 13 to the x plus 14 to the x, and of course we need to solve it. I'm going to show you my approach, how I see a solution to this problem. So first of all, let's divide both sides by, for example, 12 to the x. Let's divide both sides by 12 to the x. So dividing by 12 to the x. If we divide both sides by 12 to the x, we will need to divide all of these elements by 12 to the x. We will have 10 to the x over 12 to the x plus 11 to the power x over 12 to the x. Right here we'll have 1, so plus 1 equal to 13 to the x over 12 to the x and plus 14 to the x over 12 to the x. So we just divide both sides by 12 to the x. What we're going to do next, we need to know a really good rule, a really good property. If we have a to the x divided by b to the x, so if we have same different bases but same exponent, we can write it as a over b all raised to the power x in parentheses. So let's use this rule. We will have 10 over 12 to the power x, so 10 over 12 to the power x, so this is the first element, plus 11 over 12 to the power x plus 1 of course, and equal to the same as right here, so 13 over 12 to the power x and plus 14 over 12 to the power x. So we just use this rule right here. So as you can see, we have a lot of elements, the first one, the second, the third, the fourth and the fifth one. This is a constant, so let's work with these two and these two on the right hand side. As you can see right here, we have nothing else but a function a to the power x. So on the left hand side we have the function a to the power x, and on the right hand side we have the same. But we need to know one thing, that if a is greater than 1, then a to the power x is increasing function, and if a is between 1 and 0, we will have that a to the power x is decreasing function. So I hope you understand this property. So what we are going to do next, because if we have right here this situation, so a is greater than 1 or a is between this, we will have the next situation. We will have that our function, if is greater than 1, is look like that, increasing function, and if it's between 0 and 1, we will have, for example, this situation. So as you can see, we will have only one point of intersection. Not necessarily right here, it can be right here on the left hand side, but this is this function a to the power x. So let's think a little bit about this element. So right here we have 10 over 12 to the power x. So this is base is less than 1, and right here this base is less than 1. So I write this once more, so 10 over 12 to the power x and plus 11 over 12 to the power x and plus 1. So this function, 10 over 12 to the power x, where a is less than 1 and greater than 0, we will have that this function is decreasing function. 11 over 12, the same situation, this is increasing function, and right here we have a constant. So on the right hand side, what we will have 13 over 12 to the power x and plus 14 over 12 to the power x. And on the right hand side we have another situation, because this base is greater than 1, so right here we will have that this function is increasing and this is increasing as well. So on the left hand side, if we sum all decreasing function, we will have that on the left hand side we will have a decreasing function, and on the left hand side we will have an increasing function. So we have this situation, so only one point of intersection, so we will have only one root. But I want to show you a proof why this is correct. Let's use a derivative. Let's find a derivative, and of course we will find a correct answer. So right here, let this function on the left hand side will be our fx, and on the right hand side will be our gx, for example. So let's find derivative of left hand side and on the right hand side. If the sign of this derivative will be, for example, negative, our function will be monotonic decreasing, which is our case. So let's do this. So let's find f prime x. we will know the rule that f prime x, we will find the prime of this expression, we will have 10 over 12 to the power x times natural log 10 over 12. So this is derivative of this first element. We need to add derivative of the second element, so the same 11 over 12 to the power x times natural log 11 over 12, and derivative of 1 is 0. So this is our left function. But what about the sign? We all know that this 10 over 12 to the power x is positive always, so positive, and this 11 over 12 is positive always. But what about this natural log? We need to know about the graph of this function, because graph looks like that. If we are talking about the values which is greater than 1, we will have greater y. But right here we have natural log which is less than 1, so less than 1 goes right here, and we will have negative y. So right here we have negative, and right here negative. So plus times minus will be minus, and plus minus as well. So this function will get a negative sign. So this function is decreasing. So as you can see right here, we prove this with derivative. And let's use the same rule with the right function. So as you can see, we'll have completely the same as right here, so absolutely the same. We will have g prime x equal to, we will have 13 over 12 to the power x, and of course times natural log 13 over 12, and we need to add, we add plus 14 over 12 to the power x times natural log 14 over 12. 14 over 12, of course we can cancel it a little bit, but take a look. We'll have the same situation as in this case, because this element is 13 over 12 to the power x is positive, and right here this is positive as well. What about log? If the base is greater than 1, we will have that our y is greater than 1 as well. So right here we have positive and positive. So a sign of positive function, we will have positive, so gx is increasing function. So let's draw a graph. For example, real quick, we have on the left hand side, we don't know how this function looks like, but this function on the left hand side is decreasing function. So for example, looks like that, this decreasing function. And on the right hand side we have an increasing function. So I don't know exactly how this function looks like, for example like that. So as you can see, we will have only one point of intersection, only one point, one point, because this function go to plus infinity, this is decreasing function, and this increasing function go from here to negative infinity. So as you can see, these functions intersect only in one point. Which point this is? Take a look. Let's suppose that our x, for example, is equal to, let's suppose that our x is equal to 1. Or let's start with 0. We will have that 1 plus 1 plus 1 equal to 1 plus 1, which is not correct. Let's suppose that our x is equal to 1. What we will have? We will have 10 plus 11 plus 12 equal to 13 plus 14, which is equal to 21, 33 equal to 27, which is not correct. So as you can see, we can find a solution right now. Let's check x equal to 2. What we will have? We will have 100 plus 121 plus 144. This is our left side. If we add it, we will have 365. This is our left hand side. On the right hand side, we will have 169, 13 square plus 14 square, it will be equal to 196. And right here we'll have 365 as well. So as you can see, 365 on the left hand side equal to 365 on the right hand side if x is equal to 2. So we can say easily that our x is equal to 2. And this is explanation why this root will be one and only root. With the first method, with just a real quick method to see that this on the left will be decreasing function and this on the right hand side. If you're interested in it more, you can easily solve it with derivatives. Left derivative will be negative. This is monotonic decreasing function, and this on the right hand side is positive, this is monotonic increasing function. So one and only point where this function intersect is when they intersect at all. So as you can see, only at one point. So I hope you understand this explanation. If you don't understand, write your question in a comment. It will be really interesting to read it. And of course, thank you so much for watching. See you in the next videos.